Hey, welcome to 10.5, Solving Systems by Multiplication. We've learned how to solve systems by substitution. We've learned how to solve systems by addition. And when we did it in addition, we found in one case we had to multiply both sides of one of the equations by a -1, so that when we added it, what did we end up doing? We subtracted one from the others, what it amounted to. But we found that we could multiply both sides of the equation and create an equivalent system, or equivalent equations. An equivalent equation is one in which the solutions to the equations are identical. In other words, they represent the same line. For equivalent systems, that's a case where the systems are identical in that the solution to the system is the same. Okay, we've got some forms of a linear equation that we've talked about. Standard form, ax plus by equals c. Slope-intercept form, or y equals mx plus b. And point-slope form, y minus k equals m in parentheses, times in parentheses x minus h close parentheses, where k and h represent a point on the line. Let's look at a system that we might want to work with. And here we go. Solve the following system. Well, here's one where right off the bat we recognize that we're not going to just add or subtract those, and substitution is going to lead to fractions, and I know how much you guys like fractions, although I love them. Not everybody shares my view of these things. So let's look at what we might do to this to get rid of or rearrange it so that we can add and subtract it. Now, right now it looks like the x's are both positive values. For the y's I have both negative, so I'm going to multiply one of these equations by some negative value. And the simplest thing to me looks like, since 2 divides evenly into 6, that means I can multiply 2 by something to give me 6. So 2 goes into 6 3 times, so 3 times 2 is 6. So I'm going to multiply equation 1. I'm going to call this 1, this is 2. So equation 3 will be multiply 1 by a -3. And that'll give me a system where I have a -6x plus 9y equals 3. And this is an equivalent equation that points for x and y that are a solution in equation 3 will be in a solution in equation 1. And then I'm going to complete my system of equations. 6x minus 2y equals a -24. Going to add these together. I get 0 for -6x plus 6x. I get 7y for 9y minus 2y. And then I get a -21 for 3 minus 24. Well, 7 goes into -21 and -3 times. Multiply both sides of the equation by 1/7, excuse me. So I get that y equals -3. I need to find out what x is. So I'm going to pick an equation and put in a value for y and see what I can get. So let's see, 2x minus 3 times a -3 equals a -1. Well, -3 times a -3 is 9. So 2x plus 9 equals -1. Subtract 9 from both sides, 2x equals a -10. So x equals a -5. Well, the next thing I want to do is to check my solutions and make sure these are All right, I use the 2x equation to find x, so I'm going to use the equation number 2 to verify it. 6 times a negative 5 minus 2 times a negative 3 equals a negative 24. So 6 times a negative 5 is a negative 30. Negative times a negative is a positive. 2 times 3 is 6 equals a negative 24. Negative 30 plus 6 is a negative 24 equals a negative 24. We have our solution. Now, there are certainly other numbers we could have multiplied this equation by. We could have multiplied equation 2 by 1/3, our negative 1/3, and then added them together. That would have left us with a 2/3 fraction for y. But it could happen. It could be done. There's nothing that says these have to be integer values that we end up with when we're done, but it makes it a lot easier in doing our computation. If you're writing a program or you're using your CAS, you're not going to worry about that simplicity, if you will, and you will take a more direct route, perhaps, by multiplying by one number. Okay, next up. Okay, example 2, we're going to solve the system. In this case, we have a system of equations where there doesn't appear to be one number that I could multiply one equation by that'll give me integer coefficients where I could add the two equations together and eliminate a variable. Remember, we were just talking about we could multiply through by a fraction and have that happen, but then we'd end up with fractional values and could get a little bit more complicated than we need to. So the solution to this is to multiply each equation by some number that'll get us to the same result. So if I look at this, I want to see, well, I've got a minus 7, so if I can add the two together and get the coefficient of n to be the same, then I can eliminate it. So I've numbered them, equations 1 and 2. What I'm going to do is multiply 1 by 7, and I'm going to multiply 2 by 5, and I'll get my new system. So if I multiply by 7, 6 times 7 would be 42m plus 35n equals 266. And then for this second equation, 20m plus a negative 35n equals a negative 80. Okay, I'm going to add the two equations together. Get 62m plus 0 equals, let's see, 266 minus 80 equals 186. 186. Okay. Next, we're going to divide both sides of the equation by 62, and 62 goes into 62 one time, so I have m. And 186 divided by 62 equals 3. So I have an integer result that m equals 3 is a possible value. I need to now go back into the equation and find out what n is. Well, I'm going to use the first equation to do that. I'll get 6 times 3 plus 5n equals 38. I want to remember to use an original equation for this, not an intermediate one, because I know the original is what I'm trying to solve for. I may have messed up on the intermediate one, and my solution is fine given that I did something wrong. So I'm trying to check to make sure I haven't done anything wrong. That's the idea of checking. 5n. Okay, well, we get two results here. We get that m equals 3 and n equals 4. We're going to check this. We could graph it. We could just pop it into an equation. I know that I got it from 6m plus 5n equals 38. I'm going to put it into the second equation and get 4 times 3 minus 7 times 4, and that should equal a negative 16. That's 12 minus 28 equals a negative 16, and a negative 16 equals a negative 16. QED. We've got our answer. We've done what we said we were going to do. If I'm going to write this answer in ordered pair form, I put it alphabetically. It would be 3, comma 4. M comes before N in the alphabet. That's our solution for example 2. You could have approached this differently. I chose the path I did. You could have chosen to find multiples of 4 and common multiples of 4 and 6, but in that case you'd have to multiply one equation or the other by a negative number. And there's nothing wrong with doing that, and it may make more sense to you to do it that way. Next up is a systems problem where we're looking for integer answers to it, in that we're talking about light bulbs and lamps. And we're not going to have half a lamp. We either have one or we don't. So let's take a look. Homeowner wishes to put 6 new lamps around her home. She wishes to use a total of 15 light bulbs. Lamp style A uses 2 bulbs. Lamp style B uses 3 bulbs. Can the homeowner use a certain number of each kind of lamp and use exactly 15 bulbs? If so, how many lamps of each style will she use? So we have 15 bulbs. So 15 equals 2 times the number of A lamps plus 3 times the number of B lamps. Okay, so that gets us our light bulbs. Oh, now we know how many lamps there are. We know there's 6 lamps, and that equals A lamps plus B lamps. Outstanding. I've got a system. I've got 2 equations. But am I going to get what I need out of this? Can I multiply one by something and get an answer that will work for me? And, oh wait, it looks like I can do that, right? That's A plus B. I just have to multiply the second equation by a negative 2. That should give me a result, so we'll go ahead and do that. Well, 15 equals 2A plus 3B, and 12 equals, a negative 12 equals a negative 2A plus a negative 2B. So multiply by negative 2. We'll add those together. I get 3 equals 2 minus 0. 2 from 3 is B. So 3 equals B. Well, now by substitution, I can drop right back into this and say 3 from 6 is 3. That's pretty easy. So 3 equals A. I did a little hand waving there. Sorry. 6 equals A plus 3. Subtract 3 from both sides. So 3 equals A, right? So my answer for AB is 3, 3. Pretty straightforward. I hope this was helpful to you. Good luck on the mastery quiz. Remember to take your time thinking about the problems to sort through the kind of answers you need. See you in class. Take care.